Good evening, everyone. Welcome. Tonight we'd like to share all the latest ins and outs about cholesterol with you. And I'm hoping that by the end of this discussion that we have together, that whenever you go for your annual bloods each year and you do the normal lipogram, that you'll have a much better understanding of what that means and what are the risk factors that you actually carry. Before I really get started, I would like to just share with you a quote from a very well-known South African, and that is Dr. Christian Barnard. And I quote directly, "I have saved the lives of 150 patients with heart transplantations. If I had focused on preventative medicine earlier, I would have saved 150 million." And I think those are very profound words from Dr. Barnard. As we'll see tonight, medicine is not an exact science, and there is so much research coming out all the time. So we can honestly say it's constantly evolving. Now, if we think of cholesterol, all of us immediately equate it with heart disease. And I'm hoping that by the end of the evening, that this all gives us a much better idea that cholesterol is actually a bystander in this whole process and really isn't the cause of heart disease. But let's stop for a moment and see what the World Health Organization has to say. According to them, cardiovascular disease is still the #1 killer in the whole world, worldwide. In fact, the rate is double that of cancer patients. And in essence, 80% of cardiovascular disease is actually vascular. In other words, we call it atherosclerotic vascular disease, as we can see here from the name. And what that is, it implies that 80% of all heart disease has actually got to do the plumbing system of the heart. In other words, the blood vessels. What is also very interesting and stated by the World Health Organization is that 90% is preventable. 90%. And that is by looking at one's optimal risk factors and, of course, working on them and reducing it. Now, the challenge about heart disease is that, of course, there can be a genetic predisposition, and, of course, lifestyle factors are also very heavily involved. Now, what do I mean when we talk about lifestyle factors? Let's have a look at what we really mean when we talk about health. I'd like to stand back for a moment and remind ourselves that health is actually summarized in this slide in what I call the circle of health. As you all know, that when we were conceived in our mothers, we were given a hand of genes. And half those genes come from your father and the other half from your mother. But we do know these days that the genes actually play a much smaller role than we used to think. So more or less about 20% of what will happen to you is cast or determined by your genes. And of course, that is cast in stone. However, I'd like you to notice all the lifestyle factors or the environmental factors that are reacting with your genes, washing across your genes, or talking to your genes. They can't change the language of DNA, but they can change how your genes actually function in your body. In other words, they can turn genes off and turn genes on. And if we look at this a bit more closely, we see that 80% of our health is actually due to the environment. In other words, we are all very empowered to make a big difference to what is happening inside our body by being aware of these lifestyle factors and, of course, tweaking them. The only thing on this circle of health we can't do anything about is in the 12 o'clock position, and that is one's age. Physiologically, your peak age is 25. And as we move away from 25, then that's even more important. that we take cognizance of our lifestyle and the environmental factors and really work on them to try and maintain optimal health. So when we go for our annual bloods, what we're doing is a quick peep into the internal environment of our bodies, and we get a snapshot of what various levels look at that moment. While we're talking about this, I would like to just for a moment focus a little bit more on the genes again. In reality, the genes are a giant recipe book. And in this recipe book, there are 25,000 recipes that tell cells in the body how to make certain proteins. Each one of these proteins controls a different process. So all the processes in our complicated body are actually controlled by proteins. Now, the reason I'm focusing in on this is for every gene, there are two copies, one from your mother and one from your father. And so too, we have genes, in other words, a recipe for the apoproteins that we're going to be talking about this evening, that are responsible for carrying the various fats around in our bloodstream. There has to be a recipe in our genes for these apoproteins. And remember, if they're faulty or got mutations, we can have one from one parent, but we can also often have the same mutation from both parents. So that just puts into perspective that cardiovascular disease has a genetic predisposition, often, not always, and lifestyle factors are interacting with our genes all the time. Let's just for a moment focus on the genetic side of it. If your parents both have had different cardiovascular incidents, a stroke, infarction, a heart attack, etc., and if you know that your family, there are several members of the family that have suffered from the same pathologies, then it's very important that we check or do screening for cardiovascular disease in people as young as possible. In other words, if there is a family history of cardiovascular disease, any child that's born to parents should, at least by the time they reach high school, be properly risk assessed to see if they are carrying any genetic predisposition. And the sooner one can ascertain, are there any problems, the quicker one can actually do something about it. Let's stop for a moment and see what are the lifestyle factors. The four main lifestyle factors that influence or play a very big role in cardiovascular risk. Number one, ApoB levels. Number two, insulin resistance. Thirdly, smoking, and I include vaping there. And number four, hypertension. Please notice that when we talk about these four risk factors, lifestyle risk factors, nowhere do I mention the word cholesterol. So we see that these are really, and they are in order of importance. So let's just for a moment stop. We see cholesterol wasn't on that list, and let's just stop and really understand what is cholesterol. So cholesterol is a certain type of fat. As you can see, it's quite a complicated formula. And in total, it has many ring structures and 27 carbons. Now, there is not a cell in the body that can't make cholesterol. And that just gives us an indication of how very important this special type of fat is. All cells make cholesterol, even the brain. The liver makes the most cholesterol and can, besides using it itself, can export it for top-up in various areas of the body. Now, the fact that every cell makes cholesterol tells us once again how important it is, and therefore it obviously must have many, many functions. Well, first of all, the organs that also have very high levels of cholesterol are, of course, the gonads, the ovaries and the testes, and the adrenal glands, because that's where all your steroid hormones are made, and they all start off from cholesterol. Also, cells all have a lifespan. And as soon as you replace a cell and there's division of cells and it is replaced again, you're making new cell membranes. And we're going to see shortly how every single cell membrane requires cholesterol. In addition, cholesterol is very important for myelin, that special fatty layer that's around nerve fibers and allows us to conduct impulses in the nerve fibers extremely rapidly. Finally, we see also that under the influence of the UVB rays of the sun, you will find that the cholesterol in your skin cells, their membranes, is then converted to vitamin D. And vitamin D has many functions in the body, particularly plays a particular role in immune surveillance. So we can see that every cell needs cholesterol. And in fact, the body is so efficient that even old cholesterol is collected from cells and taken back to the liver for breakdown. And in the liver, old cholesterol is converted to bile acids and therefore bile salts. And these are then secreted into your gastrointestinal system in bile, and there it acts as your sunlight liquid. So if you've had a very big meal this evening of prawns and lemon butter sauce, you've had a fair intake of fat, you will secrete a bit more bile containing these bile salts, and that helps emulsify the fat that we've eaten, makes tiny little droplets, just like sunlight liquid does in your sink, and that aids the whole digestive process. Let's for a moment just look at a very basic diagram of a cell membrane, which of course is the barrier protecting every cell. If we take a portion of that cell membrane, we'll see that it's actually a double layer of lipid. It's a special type of lipid called a phospholipid, but in between these molecules, you'll notice a lot of yellow-looking teeth-like structures. Those are all cholesterol molecules. So we can see, even in the small little part of one cell membrane, how very important cholesterol is. In fact, cholesterol is an integral part of your cell membranes, determining that, in fact, they are not solid, as you would imagine any barrier to a cell would be. In reality, your cell membranes are a double layer of fat. And we talk about the fluidity of cell membranes. The greater the fluidity, the better these cell membranes work. And cholesterol forms an integral part of the structure. Let's just stop and think of the human brain. Now, we know our brains are composed of 70% is fat. In fact, 25% of the total cholesterol in our body is found in our brain. In other words, in only 2% of your body weight, because our brains weigh about 1.3 kilograms. So we can see that there's a tremendous amount of cholesterol in brains, and that's why the human brain is able to synthesize its own cholesterol totally. Right, so now we've seen what cholesterol is. Now let's think of cholesterol plus all the other fats that your body needs, and particularly that the liver is always synthesizing. We all know that the bloodstream is made up of blood, which is largely water-based. And when we draw blood from our arms, we are never aware of any fat floating in our bloodstream. So the point is, how do we transport all these fats, the fats we eat and the fats that are synthesized inside the liver? Now, how the body gets around this problem is it takes a protein and it takes all the various fats, which is then surrounded by this protein, which we call an apoprotein. And this little package or particle now is water soluble. So the inside of the particle are the various fats. The outer layer is the protein layer, and thus this particle is known as a lipoprotein. Lipid is another name for fat. This makes the whole little package or particle totally water soluble. So we have lots of various particles or lipoproteins moving around our bloodstream, transporting the various fats. So when we ask the lab to do a lipogram, they will then report to you two of these many different packages, namely the LDL and the HDL. But in reality, there are many other packages in your bloodstream that are separated in the laboratory, but they basically only normally report two to you, the LDL and the HDL. So this is a typical lipogram. These are the tests that are asked for when you mark a lipogram on the blood test form that you at the lab. So they will then give you the total cholesterol, they'll give you the HDL level, the LDL level, and then most importantly, the triglyceride level. And I'd really like to say that this is a crucial member of your lipogram and usually is the value that I look at first. So in our bloodstream, we have these small packages or these particles moving around in the blood that's moving rapidly. In reality, all these packages or particles are constantly colliding, crashing into the blood vessel walls as the blood rapidly moves in your vessels. So there's constant bombardment between these various particles and your blood vessel walls as the blood moves around the body. Let's look at these particles a little closer. We will see, and particularly when you've just had a meal, from the liver, you will notice that there are big particles being released called VLDL. We'll notice that they are mainly filled with triglyceride, or marked here as TG, and of course there's some cholesterol. Some of this will come from the food we've eaten, but the majority will come from the liver itself. Now, the triglycerides are a wonderful source of energy. And most of the fat that we normally have in a meal will be in the form of triglycerides, which the liver, of course, can also easily make. And the liver will use some of it itself, store some, but it will also use the VLDL to transport these triglycerides to various cells around the body, like muscles that often use triglycerides for energy, and then the balance of the triglycerides will be sent to fat cells for storage for a rainy day. So as these particles are moving around the bloodstream, and of course colliding with the blood vessel walls, etc., and triglyceride is taken up, this wonderful fuel source, you will notice that this little particle, as it's moving around, is getting smaller. And that's because the cholesterol remains inside the particle, but the triglycerides are being taken up by various cells in the body. So these are the different stages in this particle. And you'll notice that the VLDL goes from being a very low density lipoprotein to an IDL, intermediate, and then a low density LDL, and that can even get smaller to a very small dense LDL. So these are different stages in the particle life. Now, the VLDL that appears in the bloodstream just after a meal is only around for about 20 minutes. The other particles are for longer, for a few hours, and then finally, the ApoB particles are around in your bloodstream for about 2 days. But I want you to notice that on the outside of these particles, it doesn't matter what the size is. The protein that was put into the particle by the liver is called apoprotein B. Remember, that comes from the recipe on our genes to synthesize this protein. And this is what's making the whole package water soluble. On the other hand, we also see that there's what we call reverse cholesterol transport. And that is the other particle that is often measured in the lab and reported to you is called high-density lipoprotein. So in the olden days, we used to talk about this being healthy and the LDL being lethal, but that really isn't relevant anymore. So if we look at the HDL, what that does, that literally is a particle released from the liver, very small, collecting old cholesterol from around the body and taking it back to the liver. And the point of that is to take it back to the liver for breakdown. And as we mentioned before, the old cholesterol then in the liver will be broken down to bile salts, which will then be released into bile. And that helps you and I with the fat that we eat in every meal. But the big difference is of this HDL, the apoprotein on the outside of this package is known as an ApoA1. So we can see the LDL, the various sizes of the particles, leaving the liver, carrying the fats to the various parts of the body, have an ApoB on the outside. Whereas the HDL particle collecting old cholesterol, taking it back to the liver, has another protein on the outside called ApoA1. I want us just to focus again for a minute on a VLDL particle, one that is released from the liver after you've had a meal. Depending on the amount of triglyceride you've eaten, or that has happened at the same time it's formed in the liver, we will see it is packed into these particles. As this triglyceride is given off to muscles, to fat cells, etc., as it moves around the body, you'll notice that the amount of cholesterol, the green little balls you see there, that concentration remains the same, but the triglyceride concentration is getting less, and as it gets less, the particle gets smaller. So depending on the total amount of triglyceride being transported, that very much determines how small that LDL particle finally becomes. I want you to look at this picture. Here we have two people with exactly the same amount of cholesterol, LDL cholesterol in their bloodstream. Identical amount. But on the left-hand side, we see that the LDL particles are largely big fluffy beach balls. On the right-hand side, another patient with the identical level of LDL cholesterol, we notice there are many more particles that are much smaller, carrying the same equivalent amount of cholesterol. However, if we look at this diagram, we can see that the amount of apoprotein B in the left-hand side patient is much less than the amount of protein around these many small particles in the patient on the right-hand side. I'd like you to look at this diagram. Here we have 4 people, once again, with total normal LDL cholesterol levels. Please remember that when you get an LDL cholesterol level from the laboratory, what they're telling you is the total amount of cholesterol being carried in your LDL. So here we have 4 people with the identical quantity of LDL cholesterol, and it's all, in all 4 people, it's rated as normal. In Jerry and Barbara, you see the same amount of cholesterol is carried in big fluffy beach balls. In Tom and Leslie, we see the same amount of cholesterol as the other 2 is carried in smaller particles. And in fact, Leslie has the greatest number of smaller particles. Yet all 4 patients are carrying the exact same quantity of cholesterol, and it's totally normal. The 2 on the right-hand side of our screen with the smaller particles are at much greater risk for cardiovascular disease than the 2 on the left. So how do we know what size our LDL particles are? Bearing in mind that in the lab, all it is, it's telling us the actual amount of cholesterol being carried in your LDL. Now, there is a lab test that you can send off for about another 2,500 rand, and they will tell you the exact spread and all the sizes of your LDL particles. But a simpler way, and it saves a lot of money, that we have a rough idea of what our particle size is if we take this ratio. And we take our triglyceride level, which is part of the lipogram we were given, and our HDL level, and that ratio we would like under 0.87. If it is under 0.87, it implies that most of your LDL particles are big fluffy beach balls. The higher the ratio is, 1, 1.2, 2, 3, 4, as it climbs, that is indicating to us that more and more of your particles are small, dense golf balls. Now, there are many formulas that one can use, and why I particularly like this formula is that we control both the numerator and the denominator, as we'll see shortly when we discuss them. Now, why is it more dangerous? Why are we at greater risk for cardiovascular disease if we are carrying cholesterol in small, dense particles? Well, let's once again go back to the blood moving around, rapidly moving in our blood vessels. Now, there are lots of components in our bloodstream, and very often there are things causing oxidation, free radicals. Maybe we smoke, and there are even more free radicals around. For example, the body uses oxygen a lot. Very often there's a little bit of superoxide around. In other words, oxygen with an unpaired electron. But whatever the free radicals are, and they tend to increase as we get older, these free radicals cause oxidation. And oxidation of all the various components in the bloodstream, including the wall. And as that beautiful smooth lining of the blood vessel wall, as various components get perhaps damaged by oxidation, we will start seeing areas of inflammation. Now, what do we mean when we talk about oxidation? I want you to think about how iron rusts in air, and how if you cut a piece of apple, it very rapidly turns brown. Unless, for example, you took a little bit of lemon juice and squeezed it over the apple, and then you would find it wouldn't oxidize. And that's because the lemon juice contains vitamin C, which is a very powerful antioxidant. So in our bodies, there's constantly the danger of oxidation occurring, but we also have lots of antioxidants that our body makes, And hopefully we also have plenty enough food to try and protect us against this oxidative damage and inflammation. But as time, and because the LDL particles are circulating for the longest period of 2 days, it's very often happens that as the wall gets damaged through oxidation, the particles get damaged as well. Now, we can see from this diagram, this picture, that if there is inflammation in the blood vessel wall and a bit of damage, the small, dense LDL particles will find it easier to enter into the blood vessel wall than the big, fluffy beach balls. In fact, what is happening as the blood is rapidly moving through your blood vessels, and all these particles are crashing and colliding with our blood vessel walls, many of them are moving into the blood vessel wall, and then they simply move straight out again back into the blood. Often some of them move into the wall and then move right through the blood vessel wall into the lymph system. But if these particles have been damaged while they're circulating through the collisions, through oxidation, and maybe through your blood glucose level that's always on the high side, you make these particles sticky as well. So once these little LDL particles are damaged by oxidation, they turn sticky through glycation through the blood glucose. And there's damage in the blood vessel wall, they move in easily and they sort of clump together. In other words, you get a clumping of these damaged particles inside the blood vessel wall, and they don't move through, they stay there. And when this happens, immune cells, which we call, we call macrophages, follows them and moves into the wall and tries to get rid of these damaged, sticky LDL particles. We can see, even before we discuss it any further, that inflammation is actually at the root of this. Because if the blood vessel wall didn't get damaged and the small particles circulating didn't get damaged, which all leads to inflammation, that this really is the underlying problem. And so we can honestly say that inflammation is the body's silent stalker. Let's go back to the blood vessel wall once again. Here we see a beautifully smooth blood vessel wall in the top of the diagram. As oxidation occurs through free radicals circulating, and that's why it's so important as we get older and we're more exposed to free radical damage, that we have more antioxidants in our diet to protect us. This starts damaging the blood vessel wall, and we get little areas of inflammation. The circulating particles, the more they are to be oxidized, and they are the very ones that are likely to move into the wall, not move through, that get stuck there. So what happens once these damaged, glycated, sticky LDL small particles arrive inside the wall? Now we can see if we're low on antioxidants in our diet, our body does make some as well, then these little particles circulating rapidly in your bloodstream are more prone to oxidation. And if we don't look after our blood glucose level and it starts generally rising, these particles get more sticky. And as they move into the blood vessel wall, they kind of coagulate. And fortunately, macrophages then of our immune cells, in other words, they're trying to protect us at all the time, follow into the wall and try and engulf and remove them. And as the macrophages take up more of these old oxidized, damaged LDL particles, they become foam cells. Now, this is a crucial step in vascular disease. And this foam cell will then release the cholesterol and the bit of triglyceride that's in the small, dense LDL particles into the blood vessel wall. So we go back and we can see why cholesterol is not on this list. It's the actual level or the amount of particles with ApoB on the outside. That's what moves into the blood vessel wall. The greater the number, the smaller the particles, the bigger the risk. And what is often said, the longer they are, the higher they are, the greater the risk. So we actually talk about ApoB years. Because cardiovascular disease, or the whole process I've just described in the vascular wall, never happens quickly. It happens over decades. And the sooner we can pick that up, we can do something about it. So now we can see that just looking at the total amount of cholesterol in your bloodstream is really a bystander and not the actual risk factor itself. It is the ApoB itself. Let's just go back and remind ourselves, all of these particles during their lifespan, from just after a meal, where it was a big VLDL, the others as well, notice that on the outside, it's ApoB. Then I'd like you to notice that next to the very small, dense LDL, there's another particle called lipoprotein small a that I haven't mentioned yet. Let's go back to the blood vessel wall. Here we can see, and this happens slowly over years, how we get a fatty streak developing in the wall where macrophages have taken up the small, dense LDL damaged particles and have released the cholesterol and the triglycerides, a little bit that's around, and causes this fatty streak in the wall of the blood vessel. We see that if this continues over years, the fatty streak can get bigger and bigger. And with time, obviously, the lumen of the blood vessel will get smaller. The heart has to pump harder to get the blood through the vessel with a smaller diameter. And as the wall gets thicker, because of this fatty streak in it, it also becomes less elastic. So this also contributes to a blood pressure rising. Here we have a coronary blood vessel, one of the three supplying heart muscle, and we can see where the arrow is pointing, that is all old oxidized cholesterol from the small dense particles that moved into the blood vessel wall. In other words, that's all part of this fatty streak. Here we see the heart has three coronary blood vessels, and with time, this whole process, of course, as in other blood vessels in the body, this whole process of atherosclerotic vascular disease can take place. So I hope from these slides you can see that it's really a vascular problem, a problem of the plumbing of the heart, and the basis of it all is actually inflammation. Right, so let's go back to the main lifestyle risk factors for heart disease. We've discussed ApoB, and it's really the number of particles. I just want to remind you once again that ApoB All the particles carrying fats from the liver to the various parts of the body have ApoB on the outside, including an extra particle I mentioned a few minutes ago called lipoprotein small a. I would just like to mention this because this is totally determined genetically. And I think it's very important that every single person measures their lipoprotein small a level once in your life. It will never change. There's nothing you can do about it. And you inherited this, obviously, from your parents. The problem is, it alone is another risk factor. So it's like a small, dense LDL particle. It has an extra small, extra protein wound around it on the outside that you inherited. And this makes, or this lipoprotein small a increases one's propensity for strokes and for clotting. So when we do our annual blood tests and we can see we've measured the lipogram, I would like to say I think it's absolutely vital to measure your ApoB levels, and at least once in your life to measure lipoprotein small a to determine whether you have genetically have been given that or you don't. If one does carry lipoprotein small a, it's important that we know it because that's an independent risk factor that you can't do much about. And therefore, we really have to focus on the others. Right, so we see the two biggest drivers of cardiovascular disease is inflammation and insulin resistance. As we said, after ApoB levels, the second risk factor is insulin resistance. And we're going to see that these are really the underlying drivers of cardiovascular disease. How do we know what our total level of inflammation is? And therefore, I think it's very important when we do our annual bloods that we always ask to see what our highly sensitive CRP level is. This is an indicator of the total level of inflammation in your body. And remember, the higher the level of inflammation, the more likely you're going to have damage and inflammation in your blood vessel walls. As I said before, inflammation is the body's silent stalker. If we look, there's not a single pathology that can ever happen to us that doesn't start off with inflammation. So it really is something that creeps into our bodies. And if we don't do anything about it, it will lead to pathology. And as we can see in the 1 o'clock position, there is cardiovascular disease. Okay, so we've looked at the whole question of inflammation. What about insulin resistance? Why is that after ApoB the next biggest risk factor? So when we talk about insulin, we think of our blood glucose control. So when we do annual bloods every year, besides doing the lipogram, we generally look at your blood glucose level. And I would like to suggest it's equally important to always measure your blood fasting insulin level. So these three parameters give us a pretty good idea of have we got good blood glucose control. And these are generally measured in most people annually. Here we see them again on the list. Let's just remind ourselves again. After a meal, the particles leaving the liver are known as very low density lipoproteins. They're big and they're packed with triglyceride. As the triglyceride is donated to muscles and fat cells, etc., the particle gets smaller and smaller. This triglyceride is the level that we measured that was part of the lipogram. But this is also the link with blood glucose control. So we're going to see There's a very strong link between your glucose and insulin levels in the body and cardiovascular disease. Here we can see on this graph, as your triglyceride level rises, which is the x-axis, you have more and more small, dense LDL. This graph shows us, as your blood glucose, your normal average blood glucose slowly increases over the years, you're also going to have more and more small, dense LDL. In other words, you're going to have greater levels of ApoB. So what is insulin resistance? What exactly do we mean by that? Why is this such a big risk factor for heart disease? Number 2 on the list after ApoB. And how does it relate to cardiovascular disease? You can never be insulin resistant if you don't have an increased insulin level in your bloodstream. There is no way you can be insulin resistant with the insulin level, for example, under 5. It has to be increased to make you insulin resistant. So therefore, measuring your insulin level every year is absolutely vital. Besides measuring your blood glucose, measure your insulin. Because it's possible that for 20 years, your blood glucose has been nice and constant, and you were unaware that every year the insulin level was rising and rising. And because it's never measured, you're not aware of it. And this increasing level of insulin is an indicator that your body is resisting what insulin wants the body to do. And your pancreas has to secrete more and more insulin to allow the glucose to move into your cells. So your fasting insulin level really matters. It's very important. What does this hormone insulin do? It's the only hormone that is given off in the fed state. In other words, during the 4 hours after a meal, when we're busy digesting the food we ate. And insulin is therefore a hormone of eating. It is released after we've had something to eat. It's a very powerful anabolic hormone. It makes things grow. Insulin tells fat cells to store more fat. We've just had a feast. It fills up the stores of everything. So the higher your insulin, and that is determined by how many carbs you had, the more fat you're going to store. On the other hand, if your insulin is always increased and you are insulin resistant, you will never lose weight. If the insulin is increased, you will always store away fat, even if you eat very lightly. So insulin is always saying to the body, store away, store away. So it's a king metabolic hormone, and particularly the hormone that controls everything that happens after a meal. We're going to see that insulin actually is a big determinant of what we call our metabolic health. So when we think of metabolic health, there are 5 factors we look at. The first is your waist circumference, which we can measure at home with a tape measure at the level of our navel. The second, we can also measure at home, and that is what is our blood pressure. The next factor is what is your fasting glucose, and I would like to say your fasting insulin as well. The next factor is what are your triglycerides and what is your HDL level, both of which we know we determine when we do the annual lipoprotein. So these 5 measures of metabolic health are, if, for example, we have 3 or more, we then are classified as having metabolic disease or metabolic syndrome. Now, that's just a cluster of risk factors. If you have 4 of these risk factors, well, then you're in greater danger of metabolic syndrome. So 3 or more qualifies you as having metabolic syndrome. As we can see, here are the 5 risk factors or cluster of risk factors. But I'd like to just mention that metabolic syndrome, the old name for it, is insulin resistance syndrome. In other words, what we're saying is when we measure these 5 parameters, we have a very good idea, are we insulin resistant? In other words, we also know what is the state of our metabolic health. Is there a danger of metabolic syndrome or insulin resistance syndrome? What should our levels be? If we look at our waist, in the case of men, measuring at the level of your navel, it should be below 100 centimeters. In the case of a woman, 88. Blood pressure, as we mentioned there, fasting glucose, 5 or below, your fasting triglycerides under 1 millimole per liter, and your HDL level above 1.6. So we can see when we do a lipogram, an annual lipogram, and we measure our blood glucose and our fasting insulin level, we can ascertain immediately what is the state of our metabolic health, and are we at all insulin resistant, and what is our ApoB particle level. We must bear in mind if 3 of these or more are abnormal, we are classified as having metabolic syndrome or insulin resistance. This diagram gives you a very good idea of the relationship between, on the left-hand side, the whole transport of fats in your bloodstream that we've been discussing, and the right-hand side, the whole question of blood glucose control and your insulin levels. This is a typical picture of a person that will have high triglyceride levels, low HDL, high ApoB, and lots of small, dense LDL particles. At the same time, if we measure the fasting glucose, it will tend to be above the normal. If we do measure the fasting insulin, you will see it's very high, and this person is insulin resistant. And so we can see that on both sides, both areas, the basis is inflammation on the left, on the right-hand side is insulin resistance. And these two are the biggest drivers of cardiovascular risk. Do you always have to be overweight to be insulin resistant? Not at all. It's quite possible that you have a normal waist circumference and that your blood pressure is fine. But if you have low HDL, high triglycerides, and high blood glucose level, you can also be very much insulin resistant. So it's not only for people that are overweight. So we can see that vascular disease or cardiovascular disease, 80% of which is largely vascular, is really driven by underlying inflammation and insulin resistance, which very often we're not even aware of. And so if we really want to reduce our cardiovascular risk, we have to target these very strong drivers. First of all, we need to bear in mind we are in charge. We need to understand when we see our bloods, what does it mean? What are these levels? What are they telling us? And we need to monitor annually to really track what is happening inside our bodies. And then once we understand, and with annual monitoring and always looking at your cumulative report, what is the trend that is happening, we can actually take action. And the biggest area that we can do something about is changing our lifestyle. So I'd like to really urge everyone to monitor the various parameters that we've been discussing up to now. Let's have a look. How do we actually fight inflammation? And how do we fight insulin resistance? What can we do about it to actually reduce these levels inside the body? Let's first talk about inflammation quickly. Obviously, diet plays a very big role. And if we think of the right diet to fight inflammation, I'd like to mention one word, and that is color. If we open the fridge, this is kind of what we should see. Lots and lots of color. The more color we have in our diet every day, and that means every meal, the more antioxidants you are giving your body, the more you're helping fight the oxidation and inflammation. So color is a very big member of your dietary pattern every day to help fight inflammation. Another member of the diet that helps a lot with inflammation is using extra virgin olive oil, because 1% of that olive oil is a very rich mix of antioxidants and, of course, very powerful. The next component that I would like to suggest is being aware of the omega-3 in our diet. Now, I'm not a big proponent to supplements to replace food. However, I do think that most of us should think about supplementing with omega-3. Omega-6 and 3 are the only two fatty acids the human body can't make. And we can make many. And how we know that we need these is if we look at the most amazing substance on earth, and that is mother's milk. Mother's milk changes in composition every week exactly according to what that baby needs. The only thing that doesn't change in mother's milk while the mom is breastfeeding is the ratio of omega-6 to 3, which of course is dependent a bit on her diet, but generally is in the ballpark of about 1 to 1. Most of us, after we've breastfed and for the rest of our lives, have to get omega-6 and 3 from our diets. And without realizing it, most of us are getting 10, 20, 30 times more omega-6 daily than omega-3. And the reason for that is omega-6 is very rich in the plant oils, particularly sunflower oil, which is your cheapest plant oil. And omega-3 comes largely from fish and seafood. So if we think of our intake of 6, every loaf of bread we buy, every product at the bakery, every crisp, every cracker, every little thing we buy from supermarkets generally will contain omega-6 from the sunflower oil. And even the feed for cattle, for sheep, for chickens will contain sunflower oil or omega-6. So we need both. But we're getting loads of omega-6 daily without realizing it, and much less omega-3. Now the question is, does that matter? Well, we do lots of things with these essential fatty acids. The two things we really do with them is make prostaglandins. So we make one series of prostaglandins from omega-6 and another from omega-3. The body loves balance. So at times we need the prostaglandins made from 6. like when you want to start inflammation. You've cut yourself and you want the inflammatory response to kick off, to protect the body that no foreign invaders have entered through the cut. But a day or two later, you want that cut to heal. And that's when the prostaglandin, or these local hormones coming from omega-3, will kick in and suppress the inflammatory response, and everything heals. And so we can see that a member of the omega-3 family called EPA is the precursor for the body to make its own anti-inflammatories. If we don't have omega-3 in our diets, we won't have EPA in our bodies to make our own anti-inflammatories. And we will be much more prone to higher levels of inflammation in our body. So, if we go back to the circle of health, that's a summary of our health. We can see next to nutrition, I have some supplements. And in particular, I'd like to say, even on a well-balanced diet, I do think we need to add a little bit of extra omega-3 to our daily diets. Right, so that gives us some idea of how to fight inflammation. We saw that it's diet, we saw omega-3. I'd like to add, of course, what also helps fight inflammation is daily movement or exercise of any kind. Let's move on and look at insulin resistance. How do we contain that? How do we reduce insulin levels? And I'd like to add that in April of this year, a study came out in the United States where they've shown that 88% of the whole population, including children, are insulin resistant. That means 1 in 8 people have normal insulin levels. And I'd like to stick out my neck and say that I don't think it's only United States. I think it's a trend that is taking off worldwide. What drives insulin resistance? Now, we would immediately think it's food, but there are 2 factors that have a much bigger role than food. The first one is chronic stress. Now, by chronic stress, I mean when it's there all the time, and the hormone involved, of course, is cortisol. So when you undergo any stress response, adrenaline is given off for the first 20 minutes, but if the stresses remain there, the rest of the day, the rest of the time, is cortisol. Now, cortisol is trying to help the body cope with this emergency. This stress reaction that you're having to cope with is regarded in the body as an emergency. And cortisol is helping you decide, must you flee or must you fight? How am I going to get out of this emergency? In ancient man, it was either you weren't safe or you didn't have food. So what cortisol does, it tells the liver, please pour out glucose. And the liver releases glucose for the brain, heart, lungs, muscles that now have to have an immediate source of energy to either fight or flee. As the liver pours out glucose under the command of cortisol, insulin's released. And insulin will keep being released if there's a constant release of glucose from the liver. And insulin is saying, allowing those cells to use the glucose, but it is also at the same time saying, I need to store away some of that glucose as fat, particularly in the liver. So chronic stress, day after day, week after week, by not sleeping well at night, etc., is a big driver of chronic, slow, increasing insulin levels. And it's got absolutely nothing to do with what you've eaten. A second big driver of insulin resistance is chronic inflammation. Because in inflammation, when you are inflamed, there are a lot of cytokines being released, and they too drive insulin resistance. And then thirdly, the third factor driving insulin resistance is, of course, the food we eat. And of everything, this is probably the easiest area to work on. But we need to be aware that the greatest driver of insulin resistance is chronic stress. Food can either be the culprit or the cure. So let's stop for a moment and look at the role of food in insulin resistance. This is known as the SAD diet, Standard American Diet. Notice that more than 60% of the diet are carbohydrates of various kinds. Notice the rest. This is very much when we eat fast foods, everything's prepared for us, etc. This is very much the kind of balance of diet. This is what we call the Mediterranean way of eating, and it's signified by this pyramid. Notice all the color, and notice too that the largest part of this diet is plant material. I would like to say one can summarize the Mediterranean way of eating in one sentence. With every meal, try and have 1/3 of your plate animal material, eggs, meat, fish, chicken. 2/3 of your plate plant material, with as many colors as possible, which of course is all the antioxidants, and largely use olive oil for cooking, baking, etc. So how do we rather eat the Mediterranean way and resist eating lots of carbs that are so readily available? To bring down insulin resistance, we have to control the carbs. It's the biggest offender by far, and so many of them are hidden. And so I'd like to say anything in a bag or a box with a barcode, anything, means it's been made in a factory and it's going to contain the cheapest products, and they have to make it palatable. So there will be all types of hidden sugar. The second rule is when you eat fruit, eat it whole, don't drink it. Because there's a lot more sugar and fructose in fruit juices, and of course you're not getting the fiber and not getting the satiety you get from eating the fiber as well. So to prevent insulin resistance, we have to control the carbs. The more resistant you are, the greater we have to control these carbs. And we need to remember that all of us like hard food. Whenever we're sad, mad, glad, or bored, we definitely don't look for a carrot. We want something with sugar because that makes us feel better. And we've been conditioned that if you're good when you're young, you get a sweetie. So we reward ourselves with sugar when we are feeling down in any way. So carbohydrates are a huge driver of insulin. Secondly, prioritize protein. We can eat very well while we're trying to reduce our insulin levels. We need plant and animal proteins daily. And remember, with that comes all the different, as we said, 1/3 animal on our plate, 2/3 plant protein, with as many colors as possible. And then lastly, don't fear fats. It's such a built-in resistance from 50 years ago when we were told that fat gives you heart disease, fat will make you fat. And we see now that that's absolutely incorrect entirely. The big underlying drivers of heart disease are really inflammation and insulin resistance. And we can see now that carbohydrates play a far bigger role in both of these strong drivers of heart disease than what fats could ever do. We also need to remember that if we have a significant quantity of every meal as fats, particularly your healthy fats, we think of avocados and eggs, nuts, seeds, fish, etc. Fats also give us a lot of satiety, besides making food very tasty. Then besides watching and being careful what we eat, and particularly cutting out the carbs, another very powerful way of bringing down your insulin levels is by having regular periods of fasting. And what I mean by that is if we keep snacking the whole time and eating between meals and eating after dinner in the evening, then constantly, as the insulin's coming down after a meal, the next snack is taken, and again, glucose climbs, insulin's released. And so the insulin level never comes down to basal levels. And so it's very important that we rather sit down at a table, have a very good meal, we feel very satisfied, and therefore we won't have any desire to snack in between. And if there's several hours between that and the next meal, it allows the body to bring your insulin levels right back to normal. And particularly if we think of the evenings, if after dinner we have a good dinner, we feel satisfied, we enjoy our food, but then after dinner, besides black tea, black coffee, or water, we have nothing till the next morning. Then we've had a long period of fasting throughout the night, which allows the body to bring that insulin level right down. So it's a very powerful way of trying to break insulin resistance and restore normal insulin levels. I hope this has shown that what you eat, what you do, is what you get. I'm just, once again, because of the high prevalence of insulin resistance, I want to just remind everyone, what are the main ways in which we can bring our insulin level down? And remember, we want that 5 or under. The biggest driver, as we've seen, is stress. And we need to manage our stress. And particularly every year that we get older, the same things stress us a bit more because we're feeling a bit more vulnerable. So stress, a little bit of stress every day is very important. But if we constantly in very high levels of distress, that is going to be a big driver of insulin. Now, there are lots of stresses, emotional stresses in particular, relationships, many, many stresses. And so one of the things we can do to help us fight stress is to work on relationships, to make sure the important relationships in our lives, make time for them, work on them. And what's often mentioned in medical articles is just more hugging generally. We need to try and monitor and decrease levels of inflammation. If they are increased, we need to try and bring them down as quickly as we can. Then, of course, we spoke about the food. Low carbs, don't prioritize proteins, don't fear fats. Another very powerful de-stressor is, of course, getting 8 hours of sleep a night. It's a wonderful way. It's also free. By having too little sleep, it's a very big driver of stress in the body. The body has been shortchanged in its housekeeping, and that's why after a few nights of bad sleep, you move into sleep debt and you feel miserable and very crabby. So sleep is a very powerful de-stressor. As we mentioned again, fasting, we can incorporate that into a good eating plan every day, and then, of course, movement, and general movement throughout the day, and some form of daily exercise also helps us relax a bit. I hope that this discussion has helped all of us see that cholesterol is a bystander. and that the real underlying drivers of atherosclerotic vascular disease is inflammation and the insulin levels. We've seen that inflammation is the body's silent stalker. It underpins all these pathologies. We also see that insulin resistance is very similar. It also underpins almost all the same pathologies. And I'd like to end off by just looking at this beautiful oak tree. We see a very full tree with a very strong trunk. If we look a little bit closer, we can see that the insulin resistance tree is also a very strong tree. The trunk is insulin resistance, driving with inflammation all the pathology that you see in those beautiful full branches. Notice the roots that are feeding this trunk. Chronic stress, sugar, refined carbs, seed oils, sedentary lifestyle. These are all constantly driving that this trunk of insulin resistance remains strong and thick. So often we go to a medical practitioner or a GP and we diagnose one or other pathology. We're given medication to handle it. In essence, it's the same as chopping off one of these branches. But unfortunately, underlying problems of lifestyle, particularly the roots and this trunk supporting everything of insulin resistance, has not been addressed. So when we treated a disease, it's partial recovery. If we prevented a disease by looking, and the earlier the better, at our lifestyle, we get full recovery. Now, I'd like to just end off by the question I'm sure someone's going to ask me, and that is there any way we can lower the ApoB levels as well? We've just discussed what we can do about inflammation, insulin resistance, but what do we do about an increased ApoB? Now, that's what most people are onto a statin, and I want to just talk about that very briefly. Statins are $1 trillion business at the moment. They've been around for about 30 years, and most people are given a statin when a lipogram is done and they see increased LDL levels. Generally, ApoB levels have never been measured. Now, what that statin does, it blocks cholesterol synthesis in all cells of the body, but in particular the liver. So, what happens in the liver cell if you block the synthesis? Remember, we said the liver makes a lot of cholesterol, not only for itself, but also for top-up around the body should they need it. So once the cholesterol pool in the liver gets small, because you're blocking the synthesis, the liver cells insert more receptors in the liver cell membrane to take LDL particles, ApoB, LDL particles, out of your bloodstream. With the result, the ApoB levels will drop, and you will see a drop in your LDL cholesterol. But remember, the statins have blocked cholesterol in all cells, and they are able to cross the blood-brain barrier. So statins also enter into your brain and block the cholesterol synthesis there. Generally, if there is somebody that has a lot of risk factors, most cardiologists will put you on a statin and probably include a few other drugs as well. There are drugs called PCSK9 inhibitors, and these are drugs that prevent the LDL receptors undergoing their normal lifespan. In other words, they make sure that there are always more LDL receptors in the liver cell membrane to take up these particles from the bloodstream and lower the levels. Then there's another drug called ezetimibe, and that inhibits absorption of the little bit of cholesterol from our food, from the gut itself. And then there's a new drug that's on the market, but rather expensive, called bempedoic acid. And this blocks the cholesterol synthesis, but in liver cells only, not throughout the whole body. So very often, if there are a lot of risk factors, or if a patient's already had a cardiovascular incident, they will be put onto statins plus several of these other drugs together to try and bring the ApoB levels down as low as possible. But I would like to stick out my neck and say that by taking these drugs, and it is good to lower the ApoB levels, but it's a little bit of false security, because the underlying drivers of inflammation and insulin resistance have not been addressed. Are there any side effects of the very commonly used statins? Yes, of course, because you're blocking the cholesterol synthesis in all these cells throughout the body. The most common side effect is muscle soreness, aches, and fatigue. Now, as for all drugs, every single person responds differently. So some people might find a lot of muscle soreness and aching from a statin, whereas others, again, might not experience it at all. We find also that the liver enzymes AST and ALT levels increase. It's an indication that liver cells are a bit irritated. And we also usually see that if there's a rising incidence of insulin resistance. And very often that happens in patients, that when they're on the statin, they actually start becoming even more insulin resistant. Because of the fact that the statins can cross the blood-brain barrier and move into the brain and inhibit the synthesis of cholesterol there too, often people experience a kind of brain fog, perhaps not as sharp as always, and perhaps also changes in memory. And unfortunately, in some people as well, another side effect of the statins is if they do have the genetic predisposition to lipoprotein small a, it's inclined to increase it a little bit further. So this doesn't mean everybody will have these side effects. There are various statins on the market. If you do experience any of these, it's good to talk to your cardiologist and let him perhaps try another statin. But I still want to emphasize, it might bring down your ApoB levels. In fact, it definitely will. Your LDL cholesterol will come down, and that's fine. But the underlying problems, the real risks for cardiovascular disease, which is inflammation and insulin resistance, has not been addressed. So we must never forget, and these two, the best ways of addressing them is without a doubt by altering lifestyle, understanding, and then taking action. So I'd like to end off by saying we all want to live as long as possible, as well as possible. And I'd like to go back once again to what the very well-known Dr. Chris Barnard said, and that he saved the lives of 150 patients with heart transplantations. But if he had focused on preventative medicine earlier, which is basically lifestyle medicine, I would have saved 150 million. Thank you all very much. I'm more than happy to try and answer some questions.
Any questions, anybody?
Good evening. No, that's Chanel Bunting that's speaking. How are you?
Hello, Chanel. I'm fine, thank you.
Good, good. Thank you very much. That was a very, very informative talk. Could I just ask you, please, what is your view on eggs? You know, that has been something that we've all discussed. We've grown up with it, and some people believe that you shouldn't eat a lot of eggs, and other people say eating eggs doesn't make any difference to your diet as far as cholesterol is concerned.
Thanks for that, Chanel. I absolutely agree with that. Your liver is synthesizing about 2,000 milligrams of cholesterol a day.
Yes.
If we have a little bit of cholesterol in our diet, the liver will make the balance. So say we have 100 or 200 milligrams of cholesterol, the liver will make, say, 1800. But that fixed amount leaves the liver daily. If we eat no cholesterol in our diet whatsoever, like we are a vegetarian, then your liver will make the full amount. So I'm very prone to eggs. I think this is the wonderful source of nutrition. Not expensive, and you can do so much with it. And besides the fact that I think why eggs are so important in one's diet, it's a very good source of vitamin D, about the only source, and also a very good source of B12, vitamin B12. So I think 2 eggs a day is wonderful.
Excellent. Okay. Thank you for that. That answers my question.
Thank you, Chanel. Go ahead, Mary. Mary Fletcher, you want to ask a question?
Yeah, thanks. I just wanted to ask, is etoricoxib, which I take as an anti-inflammatory, is that a statin or not?
Mary? No, it's an anti-inflammatory.
Okay, thank you.
But remember, Mary, every anti-inflammatory you take orally will have side effects as well.
Right.
So it's
okay.
I regard it as emergency. It would be better if you could bring down those levels of inflammation yourself, and maybe add omega-3, take omega-3 daily.
Yes, I do. Thank you for that. Thank you very much.
Thank you, Mary.
Cheryl Lucas.
Go ahead, Cheryl.
Cheryl.
Hi, Nola. Wanted to check with you saying people not getting insulin tested, maybe getting glucose tested, and have been insulin resistant without knowing for a long period of time. How, does it make a difference of becoming insulin sensitive again? So can you just maybe speak a little bit to how do you walk that back?
Okay. I'd like to, Cheryl, very good question. I think the reason why very few people measure insulin levels themselves is because there's no drug to reduce it. So, generally, if your blood glucose is high, they'll give you glucophage. But there's no drug to bring down your insulin levels. And unfortunately, it hasn't been measured in the past much. And the longer you've been insulin resistant, not only are the levels maybe climbing and getting higher and higher all the time, but with all hormones, you won't get you can bring them down, but it's not going to happen within a day or two. One will actually have to, and the longer you've been insulin resistant, probably the longer you're going to have to work on it. But the good news is you can totally reverse it. And that's why something like type 2 diabetes, which is basically insulin resistance, that's climbing all the time, takes like 10, 15, 20 years.
I just wanted to ask you a question about inflammation. Because I'm past the menopause, about 5 years ago, I attended a hormone doctor from the States, and he put me onto animal protein. And so I've been forming a carnivore diet, and I found that really, really helped in terms of bringing the inflammation it's completely gone. And as long as I stick to just that plus vegetables, it's working extremely well for me. I just have one strange thing. Even though I'm following already a lot of your principles, from time to time, about once a month, I start becoming very thirsty, and I have to pee a lot. And that seems to sort of suggest that something's wrong with the kidney or something or other. Is there a reason for that? Is that a form of inflammation?
No, I would think it's more likely that you get kidney problems with insulin resistance. And if you do experience that, the reason the carnivore diet, which you're focusing on meat and vegetables, why it's really working is that you've cut out the carbs almost completely.
Yes.
So sugar is a big driver of inflammation, and most of the sugar generally is hidden. And they've now got something like 69 names for sugar on the market. So that a lot of times when you read a label, you don't even realize that that's a form of sugar.
Yeah. Yeah.
Sorry.
Yes.
sorry, about your kidneys, I would definitely go and have kidney function assessed. Very
Okay.
important.
Yes, because sugar, it can't be. I've known since 16 or 18 that I'm highly sensitive to sugar. So since I've been 18, I really eat zero sugar, zero. Because I gain weight with it.
Yeah, I think the kidney is a different thing now. I think that is definitely something you must investigate.
Okay, thank you very much. Thanks.
Okay, thank you all very much. I want to say a very big thank you to Gert, who's been the controller and has helped me enormously. Thank you very much, Gert. Thank you all very much for giving up your Sunday evening. Enjoy the rest of the evening and bye.